Hey everyone, welcome to the second video in the series of quantum computing. And if you remember in the last video, we had discussed that how the series will be more developer friendly. I mean, if you're interested in more academic aspect, then there are tons of resources out there. But what I'll try to do is in the entire series, I'll try to cover up resources that you as a developer should go through to be more comfortable and introduce yourself to quantum computing. So in this video, we are starting with IBM Qiskit. And the subsequent videos, we'll be talking about D-Wave, Xanadu, Penny Lane, and Google Quantum and other stuff. So in every video, what I'll do is I'll take you through the resource, through the entire resource. I'm not going to walk through each and every resource, but I'll give an overview at how you should approach the resource. Because what is happening and what I've observed is that the people who are trying to get into this domain, you start with one of the articles and there is some mathematics or let's say some information required that is present in somewhere else, and then you keep jumping between articles and you're not able to complete one stuff before in one go. So let's say either you are not competent with the mathematical part, or either you are not competent with what problem the article or resource is trying to solve. So currently, I am on IBM Qiskit's page, and this is the learning page that I'm on, and they have a lot of resources on here. They have linked their YouTube channel, they have their Qiskit Medium blog. But we will start with the first thing that we should go through is the understanding quantum information and computation section. So once you go to the section, they will take you to couple of chapters. Just one thing to note, at the time of the recording of this video, the chapters multiple systems and circuit protocols, they are working on it. It's currently not here, but you should definitely go through the single systems chapter because it will give you a brief understanding of the probability, the state vectors, and what do we mean by quantum states, and what is the basic difference between quantum information and classical information. So once you have gone through this, you'll have some idea of the mathematics that is involved and basic notation of how we represent quantum states. The second chapter that you should cover is the introduction course. Again, this chapter will make you understand that why quantum computers are even required, what sort of problems are intractable, let's say not solvable on classical computers, and what is the promise that quantum computer gives us. Now, there's one particular part that I like about this article is that they have tried to separate media hype and reality. So, if you read about quantum computing from any media journal or let's say any news article, they try to write superfluous stuff out there. But the actual problem is that in terms of hardware, we are still struggling. And we hope that in the next couple of years, we will be able to commercialize it. I don't know what is the exact timeline for this, but they have made it clear that currently there are very few applications that you can call sort of on a commercializable scale. So the chapters like atoms of computation, what is quantum, and entangled states, these are important to understand the quantum advantage that they talk about. So in the why quantum computing section, they introduce you to the problem, and eventually they're trying to establish that along with the notation, what are the topics that you need to understand, that why the very cause of quantum supremacy or quantum advantage is there. Now, once they have taken you through all this, and now once that you have developed some sort of intuition about qubits, they will take you through one of the classic algorithms, that is Grover's search algorithm. And this is basically a problem where they are trying to query an unstructured database. And by unstructured, I mean that there is no sort of early information that you have about how the data is being stored. So let's say you cannot apply something known as binary search. And there is a very beautiful representation. They have showed it graphically over here, if I remember properly. Yep. So this beautiful geometric demonstration and explanation they have given at the end. And I think this is something that I didn't find in any of the other resources. So this was really something interesting that I found. So once you are done with this section, this introduction to quantum computing section, then you are equipped enough to try to explore other sections. I will say that before getting into something like quantum machine learning, you should explore the other sections like multiple qubits and entanglement, quantum algorithms and applications. Let's explore this section, and also side by side. Let me open. Yep. Let me also open the other section, which was, just give me a second, which was, yep, the quantum circuit section. So if you remember, I don't think I discussed this in the last video, but there are a couple of approaches in which you can uh, tackle the problem of quantum computing. So two of the most famous approaches are annealing based, that D-Wave is following, and the other way, the approach is gate-based approach. Okay, so what IBM follows is the gate-based approach, and here what you have to do is create quantum circuits. So this entire section, quantum protocols and quantum algorithms, will take you how to develop circuits, what is a quantum circuit, and basically through all the algorithms, there is one famous algorithm known as Shor's algorithm, which is like if you go on YouTube and search for Shor's algorithm. So I think there are a couple of channels where Shor himself has explained about the algorithm and how he came up with this algorithm and what was the agenda behind this algorithm. So I'll encourage you to search this algorithm on YouTube, because what better way to learn about any algorithm than the person who invented the algorithm himself. Anyways, so now we've seen what are the introductory resources that you should follow. And once you have gone through these basic resources, I think then you can jump to other resources also. And you can go through the other resources by other authors on how all these stuff works. So to end the video, what I'll do is I'll try to recap. You'll start with basics of quantum information, then you'll go to introduction course, then you'll try to go to the quantum protocols and quantum algorithms, quantum states and qubits, and then you can jump up to the other applications so that you are not confused with the terminology whenever they are trying to write some equation in terms of states, or they are trying to refer any kind of unitary operations. Then you're not confused that, okay, hey, what are they actually talking about? So this was the overview of the Qiskit resource, and this was a more theoretical approach. Once you have done through this, then only I think I'll advise you to go to the quantum machine learning course, because understanding how these circuits are built, what are parameters, what are states, these things are more important before getting into something like which sounds super cool, like quantum machine learning. Okay. In the next video, we'll be talking about D-Wave, and I think we'll take 2 to 3 videos for, not 3 videos. I think 1 or 2 videos for D-Wave, and then we'll go to stuff like Pendleton and Xanadu. Thank you. We'll see you in the next video.